All right, so this sample examiner notes thing we'll look at later. The main one is the PPT that we just opened. Okay, so we're going to start with this. So the logic here, like I mentioned yesterday, is although you claim you're going to do a whole bunch of studying and preparation and blah, 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 the reality is you're probably not.
Yes, we are.
Okay? You might. Some of you, probably not all of you, but some of you may. A lot of you may not. That being said, we still have to get things done in term one. And you probably are already starting to feel there's going to be a lot of things piling up in the beginning of that term one. All right? So why? What purpose does it serve for me to wait until September to assign you this IA so that there's just one more thing to do? Instead, I'm going to assign it now, give you over almost 2 months to do it, right? A month and a half, basically. Well, more like 2 months. And then you just hand it in week 1, and then it's done. And there's no more IAs for term 1 in bio. Is everyone processing what I'm saying? Yeah. Okay. So that involves you doing this IA during the summer. I'm telling you, you could sit down and do this in 1 day if you really needed to. Ideally, you should do it over the course of a few days with a little bit at a time, but it shouldn't be too arduous of a task. Okay, it shouldn't be too demanding of a task. I will explain to you now how to do it and what is required. Let me know if you have any questions. Basically, this is based on looking at the sort of that paradigm shift we ended last class with the ulcers and the cancer, or the ulcers and the H. pylori and cancer. There's potentially a link between H. pylori infection and stomach cancer. So that's where this reasoning comes from. Okay? So maybe there's a question to be asked like, is there something that causes rates of cancer to be different in different countries? Example, H. pylori infection. Okay, so if we use this example, we could design an investigation where we try to compare rates of H. pylori infection, this bacterial infection, and rates of stomach cancer. We know that H. pylori is one of the causes of ulcers, but is that somehow also related to cancer? So that could be an example of an investigation you find. You need to find data for infections, you need to find data for cancer, and then somehow put them together to see if there's a link between the two. All right? The theme of this IA is correlation. Right? We're looking for correlations in this investigation. So you could research the incidence of stomach cancers maybe globally and see if certain populations get cancer more often than others or less often, or is it related to the incidence of this infection or the incidence of some other random thing. There's a lot of freedom for you. I don't even mind if you don't focus on cancer itself. If you want to focus on something completely different. We're sort of fitting it into D.2 topic with digestion, but I don't mind. We've done human physiology. If there's some other illness or disease that you want to look into, that's totally fine with me. So how do you formulate your research question as you're getting started? Is there a relationship, and basically these underlying things you can replace with what you want. So some factor, what does some factor mean? This is where you get your sort of humanities angle. So it could be something completely unrelated to biology. It could be economic status. It could be social status. It could be healthcare. It could be education. It could be something about water pollution. It could be about air pollution. It could be about any number of things, right? Something. Basically, you're like, oh, I wonder if this causes this to be worse, right? Does this make this better? And you just need those two factors, right? The second variable is your illness or disease or whatever it is, right? So although we're focusing on stomach cancer, you can do whatever you want. You could, yes. I don't mind as long as you do it with the.
COVID when you said some factor.
Sure. If you do it with, I'd say appropriate sensitivity. The data might be harder to find, right? Because it's so like right now, but it might be available.
Is there a website to get?
Yes.
Yes, I'm going to show you.
I did it for my math IA.
Okay. So, and it doesn't have to be incidence. It can be mortality. It could be survival. It could be the age that you get it. It could be the sort of age groups. Could be Sorry?
It doesn't have to be
It doesn't even have to be cancer if you don't want it to. I don't mind. I don't mind. Okay, this is I'm giving you some freedom. So that's the first thing. You need to pick a research question. All right? So basically that involves picking two things. I want to see if this is somehow related to this. All right? Step one. Here are a lot of resources that can find you data. Now, I would say the easy one is picking a question. The difficult thing is finding out if the data exists, so that you can actually.
The data.
You could. That's the other thing. So you might want to actually go in reverse and say, "Oh, I found this interesting data. Now I can formulate the research question." It's not the way it's supposed to be done,
Sounds so.
but in this way, in this case,
I want my grades.
it can be tough. Okay.
That's like, no, I want my grades.
Reads libraries.
So there's lots and lots of
Applications.
places. The best way is if you can just straight up download an Excel file. Some places don't let you do that, so you may have to like download like just like a table and then like somehow put it into Excel depending on how you use it, how you want to use it. So here's the big thing. The big difference between this and an IA that you would that we would do in class is in class we collect the data as a group in the lab or doing something, right? And we're physically doing the experiment. This is called primary data. What we're doing here is called secondary data. We're taking data that someone else found for some other reason, and then we're going to manipulate it ourselves to find a different thing, to make a new relationship with some other thing. So that's the major, I'd say the only pitfall that people fall into is like they will find data and then they'll just like take that data and then just like present it as if it's like a book report. Like, this study is my analysis. Like, no, you can't do that. Like, World Health Organization says as this increases. Extract, input, and then I found that as this increases, and blah, 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 blah. In conclusion, that doesn't work.
What if our thing that we write ourselves somehow clashes?
That's so. But it, in a sense, it kind of shouldn't, right? So what you want to keep in mind is like you're trying to find out something that maybe hasn't been done before.
What?
More research. Oh,
Right? Like, in a sense, your research question should be something that maybe someone hasn't tried to compare yet.
It's like writing an EE.
In a sense, yeah.
Oh, no.
Even for your II, it should be like that. It should be something that hasn't really been done. Okay? So the key is here, you must use the data in a new and creative way to show a new relationship. All right? Here's the, okay, I want to run through this because I want to get to the stats, but this is all the same. Okay? Full thing. PE all the way to communication. What's new? Obviously, there's no safety, unless you like staring at a screen for too long is safety.
Oh, my eyes.
They accidentally twist your finger.
Carpal tunnel syndrome from typing too much. Not many materials, and you could mention ethics in terms of like maybe like where the data came from or like generalization. It doesn't necessarily have to be there. Everything else is basically the same. Many opportunities for limitations, right? When you're coming up with a conclusion based on secondary data, there's so much that you are not in control of. So trying the control variables, we had a good question in the last class, which is like, what are your controls if you're just using someone else's data? Well, the controls are your parameters, right? What years is the data from? What age groups is the data from? What countries is it from? Is it just male and just female, or is it both? Is that controlled? So basically, what did you try to control based on the data you found? Right? 'Cause other than that, you weren't there when the data was collected, so you can't speak to that. You can only say this data was collected in this study. We're not using it for something else. So that would also go in your methodology or in your variables, right? Variable 1, levels of infection of H. pylori in China from years, blah, 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 blah. Data was found on this website. That's your variable. Then the next variable. Okay, this is all the same. Your method is not going to be too much about how you carried it out. Like, I don't want to say, sit down at computer.
Open your
Open
web browser.
Web browser.
Go to the search tab.
Yes.
Type 3
Google.
W's, 1 dot, 2 slashes.
Google.com googlescholar.com, scholar.google.com, search databases,
Open
bio
iTunes.
IA.
Open music. Open music.
Yes.
Play some music.
Bio IA ideas. No, don't tell me that. Just tell me how you found the data, how you analyzed it is really your method, right? How you plan to process it. So even that will be quite short. It won't be very long.
I paid Johnson for it.
Now, these red things, this is what I'm going to
yeah.
teach you next. Okay, these three things: R value, statistical significance, and R squared value. This is going to be your data processing. Really, we're learning how to do this.
Wait, isn't R like?
Oh wait, is it
Is
our
it
I'm
calculation?
sure you have learned this.
It's our variance.
Is it a variance?
No, that's
R squared is
standard
variance.
deviation. That's
And it's not standard
variance.
deviation, right?
Yeah.
No, wait.
Wait, no.
Oh,
R
Standard
no,
deviation is
correlation.
R squared.
R
No.
squared.
No.
R squared is your
Variance.
variance.
No.
It's something of correlation.
Yes.
R.
Wow.
I remember you can get it from.
We're learning this
GDP.
math studies and I forgot.
I remember you can get this from the graph, right?
Yes.
You don't even have to calculate.
One
Okay.
variable
Ready?
statistics.
No.
I'm gonna explain this to you as much as I need you to do it, and then you can obviously it should be the same as what you've learned in math, but maybe in a more simplified manner. Okay, keep going. All this stuff, blah blah blah. Great. What is the statistical test you're going to do? We're going to do or apply Pearson's correlation test. Okay?
Oh, Pearson.
Yes. Pearson correlation test.
It's this guy.
Pearson's
the-
product.
The film my.
Pearson's product correlation.
I got all the
What in the
explanation.
world is a person?
Pearson.
Pearson's.
It's called a peer. And then it's
Person.
son of a peer.
Oh,
Pearson
Pearson's
correlation test. Correlation. What does correlation mean?
How close
correlate.
the data related.
How close they are.
How
I don't think close is the right word you want. How?
related?
Yeah, I guess I would say strong. How strongly they're related, right? So what Pearson's test, which is R, okay, so we have R value. These are the three things we're going to learn. One, R value, statistical significance,
I squared.
and
I thought we only use R squared since it's a
No.
accurate.
R
is for
squared.
linear. R is for linear, and R squared is for very also linear.
okay. So the R value is the strength of the relationship. Strength of relationship between variable x and variable y. So meaning, is there a strong relationship between x and y, i.e. when x increases, y increases, or when x decreases, y also decreases? Or is there no relationship? It's totally random. There's not, everything is all over the place. This will always fall in a range between -1 to +1, right? In a graph, this relationship is +1, meaning there's a direct positive correlation, like a 1-to-1. No relationship would be something like this. This would be 0, and something like this would be -1, meaning a very strong negative correlation, right? Or even direct negative. Anything between this and this would be between strong to weak, right? So you want to say strong to weak correlation, and between here the same thing, strong to weak. So this at first is a little bit arbitrary. So like if it's plus 0.9, that's pretty strong, right? That's something like this. So that's still a pretty strong relationship. But something like plus 0.3 is really like that. It's not so strong, right? It's closer to 0. So it's not as strong of a relationship. So this is how you're going to kind of analyze initially your data. So you plot it as a scatter, and then you find R, and R will give you a number somewhere between -1 and +1. Yes? So far so good? what we are calculating is not causation. We kind of saw this on the last test, right? Correlation means, yes, when this happens, this happens. But it doesn't mean when this happens, it causes this to happen. You see what I'm saying? For example, A and B happen regularly together. That's a correlation. There's a regular occurrence of H. pylori infection and stomach cancer. Does it mean that H. pylori causes cancer? We don't actually know that. That would be the next step. So your job is to just find a relationship or lack of a relationship. And then you would present this paper to some medical team of professors and doctors and be like, yo, I found something very interesting. Please go cure cancer because I think this thing causes cancer. I can't be
You're
sure.
like, ha,
I
kid."
only found a strong correlation, but maybe it's something worth looking into, right? So this is a two-step
Ha,
process.
kid.
We can only do the first step.
Get out of here, kid. Get a university.
So of course, number two is this is not true. Just because A happens when B happens doesn't mean A causes B. All right? So without a real experiment, what we're doing on the computer, without the experiment, we can only say that there's a relationship. Okay? Then the scientist's job is to determine the cause. What is causing this?
Wait, so if the cause is found, it actually is a cause?
Potentially, that's the next level.
No, I mean, like, do you still say it is a correlation, or can you say it causes?
I mean, it's a
But there's-
whole different experiment, right?
Yeah, but if it's like
Yeah,
established.
yeah.
It's like
Try.
how our textbooks say.
Well,
smoking
those are
cause-
tested. Those are tested facts.
Smoking causes lung cancer. It's not a
Right.
correlation, it's
It's-
actually a cause.
Even now, when I have that here, right? Like smoking and lung cancer is still, we don't know the exact cause, right? Like what is the exact compound that's mutating the DNA that's, you know what I'm saying? Like we know that it causes it, but we don't we can't exactly be super specific as to what causes it, right?
So it's
We know it causes it. There are other things that we definitely know don't cause it, like vaccinations and autism, right? There might have been a relationship, but that's just that's
autism
the
now.
anti-vaxxer
Autism.
crisis, right? Obviously very stupid.
Wind turbine and illness.
5G and cancer.
Exactly.
Come on, people.
Yes, that's the same as the wind turbine people who are like, you can't put up a wind turbine, it gives me migraines, right? Or it's causing cancer. Like,
What's
no, it's
migraine?
like headaches.
Oh.
It's like no of those. You use too much phone, you get radiation.
Sure. These are maybe correlations, but maybe it's also that we just use phones more, and also people are being diagnosed more with headaches because we have better ability to diagnose. Doesn't mean they cause each other,
It's like
right?
TOP.
So we can talk about radiation.
If you can find some data, yeah.
Yes, some productive.
Okay, now,
What did I see?
yes, okay.
What?
This is the equation for calculating R. You don't need this. I mean, you do need this.
We have this in our math tag.
You want to put it on your sample calculation? Relax. Sample
Copy paste this
To
calculation?
make it look smart.
Yes, exactly.
That's exactly what I did for IA.
Instead, I've given you a whole bunch of ways of how to
Oh.
calculate using Excel, how to calculate using your calculator.
Let's
It's
do-
very simple. This is a video that takes you step by step how to find R.
we make
Okay?
G-
Just copy what the video tells you,
Beep, boop.
and it will give you the answer R.
Get calculator. Beep beep boop boop. Beep beep boop. Get it.
Okay. Now, I want to show you a couple of things. That's just one step, right? So one step is calculating
That's just one IA.
R.
kids.
But
That's just one IA. Here's the second one.
You have 3 more to go.
no, bro, this is what I'm trying to tell you. After you do this is the last practice one, then we do our real II after that. And then
Wait, IA is a practice?
Yeah?
What?
IAs are practice.
IAs are all practice.
Yeah. For the actual.
I mean, they go on your report card, but the real one is after this one.
But does IA affect our PG?
Oh,
Yes, obviously. Anything.
I don't even understand the IB curriculum. I just do whatever.
Maybe you should start there. Anyway.
Does IB cause cancer?
I think I do. I think I
The
do.
last time, Mr. In English class, Richard is like, there's a question we have to answer. Everybody want to escape reality, and then Richard's answer was IB is cancer. I love
Really not,
animation.
that's not a good way.
IB
Okay.
causes cancer.
First of all, let's not joke about cancer because it's pretty serious. Next is this first link below the PPT. Looks like this. Okay? I legit just took pictures from this textbook because it's the best explanation I could find.
Below the grass.
So it tells you why it goes through the equation for correlation coefficient, right? The R value.
Why does this one look less like complicated than the other one?
It even shows you a table you could use if you wanted to put all the values, boop, 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 like calculate it. You don't necessarily have to. But what it also does is it goes through how you can calculate statistical significance. What is statistical significance compared to what we just did with the t-test?
How significant?
Significance level.
So in like normal words, what do we want to know?
Is it important?
Is it important? Yes, really. Like, does it actually matter, right? What we really are finding is this relationship random or not random? Right? Random or not? And we can do this by using a table of p-values, which is very similar to the t-values table you did before. All you have to do is you take this R value that you found here, you take it to this table, again you just find it through this link or you can look one up,
Holy shit.
and what was the,
Familiar.
0.05.
0.05 is what we usually look for, right? So what we're going to do is exactly like before, we're going to find the degrees of freedom, okay? Degrees of freedom is the same way. What was it for t-test?
20 minus 2, 18.
But what's 20 really?
It's like this data sets.
How many data sets do you have, right? How many values did you use? So n, it's actually n minus 2 degrees of freedom is n minus 2. So if you're doing a correlation, you take every piece of data. In this example,
Wait, it says his data sets is 12 minus 2. Does that mean he has 6 data sets?
yes, exactly. I was just going to show you that. So look here.
This minus.
So this example, they're comparing the mass of the seed with the number of wrinkles to see, does mass affect number of wrinkles of these seeds, whatever the plant. Doesn't matter. Okay? But yes, exactly what William said. There's 6 matched pairs. So here's the mass of the seed and the wrinkles. Mass, wrinkles, mass, wrinkles, mass. So 6 of them. But that means there's actually 12 values, right? 6 of variable x, 6 of variable y, which gives me n equals 12. So my degrees of freedom is 12 minus 2, which is 10.
0.57.
Right? Now, this is a slightly different way of doing this. Before, we would take our R value and compare it to a table of critical values. In this case, just a bit different. Instead of looking at it, so what we would normally do is you might come to, okay, 10, 0.05, and say 0.5760. And compare, oh sorry, their calculated R value is 0.97, just so we're aware. 0.99.
So you use R value?
Yes, you use the R value. Okay, his R value is 0.97. And you might say, okay, then I compare it to this, and my R value is bigger than the 10, and 0.05 is bigger than that. That's actually not how we do it. In this case, you're going to follow that row, degrees of freedom, until your number is not closest, but is lower than the next row. So watch, 0.97, right? I'm going to go degrees of freedom up to 0.5. That's the one I'm interested in mainly. 0.97 is higher than this. So that means that my percentage of chance is below 5%. Now I'm going to check to see, like, maybe it's even more certain, right? Meaning less randomness. I jump to 0.01, which is 1% chance of randomness, right? And my R value is even higher than this. So now I'm like, oh, it's even less chance of randomness, less than 1%. Is it possibly less than 0.1% chance of randomness? I compare to here, and it's to the right of this, and yes, it is. That means that 0.97 is to the right of the highest range of this table. That means that there is a less than 0.1% chance that the significance, the relationship that we found, is due to random chance. So the way you use
correlation. I mean, strong significance.
very statistically significant. right? It is more than 99.9% certain that the relationship is accurate. That is due to the relationship, not due to random chance.
So the number of beans you eat in the city.
I just want to see how they concluded it. So they have here. The judges here. At 10 degrees of freedom, a value of 0.97 gives a p-value less than 0.01 or 0.1%. So that means less than 0.1% of the observed data is due only to chance. Thus, the correlation is 99.9% certain.
And this is
Voila.
standardized.
And this is all, you just find this table, you take your R value, compare it to the table, and you use whichever column you get to basically tells you. So let's say the number was not 0.97, let's say it was 0.75, right? So I go here, it's higher than that, it's higher than this, oh, but it's not higher than this one. So then my certainty is only is only 1%. Not, sorry, 99%. Instead of,
between 1%.
yes, so between 99 and 99.9%, you could say that.
So as long as the value doesn't surpass like
Yes, so you stop as soon as it's lower than the next column.
Interesting.
Yes. Okay, so that's our statistical significance, meaning the certainty, right? Percent certainty is what we're trying to find. There? So that's 2.
we're done.
No, there's one more, come on.
No, isn't that just for
You have not, if you look at your rubric, the
R squared.
consideration of error, right? Consideration of error.
Wait, no.
So this last link here says how to calculate R squared.
Don't just square all the values.
Well, yes, but what does it mean? What does it mean? All right, here, there's so many ads on this page, it's very weird.
Not secure.
Close it.
No,
Close it, then it'll go to it.
Ad block.
Not
Ad block is
secure.
basically malware, let's be serious.
Yeah.
Okay,
Statistics how show how to
So, more specifically, what does the R squared, what did you learn in math? What does R squared give you? What does variance mean though?
That little sigma sign.
No, but
Six.
what does that actually
It
tell?
means that
I don't know what it means.
the variant.
I learned it in math class, but I forgot.
I didn't know what it was.
Alright, fine guys, I'll take out my math textbook.
Yeah, me too.
Is it downstairs?
This is the red one.
I have it.
Why did you bring it?
Let
We have math today.
let me try to help you out. Ready?
This is the red one. The
Oh, the
last
last one.
chapter of the red one.
It's blue, black.
They don't have the black one.
Oh, that's
We have the orange one. The rookie. The rookie version.
Okay, ready? Watch this.
Wait, I think.
Watch it.
Did you put
Watch it.
X, Y? Wait. What?
Okay, watch this.
Which one is X, which one? We confused.
me watching.
Okay, here are my data points.
For what?
Okay, this is example 1. This is example 2. Don't stand in front of my camera, bro.
Hey guys, so
We're just gonna need this. Okay, here in this relationship, what would you estimate is my R value?
1.
1, okay? Because the trend line is like this, approximately R equals oh my god, what am I doing? R is approximately 1. How about this one?
0.759.
I cannot see the.
There's data points here.
Actually, wait.
It's also one.
It's also 1, isn't it? Because if the trend line
Oh,
is like
it's
this,
how closely the things are packed.
R equals approximately 1.
Oh god.
But is this the same as this?
No.
It shouldn't be, but R tells us that it is. Okay, so what does R squared tell us?
The strength of.
The close, how
R.
close the data sets are to the line.
Exactly, right? The variance, when you say variance, you mean the variance away from the R value.
Yeah, didn't we do this in the last IA?
So that's standard deviation. Same idea, except that's a mean. This is a correlation,
Fine.
right? Standard deviation is calculating variance in a mean.
I heard that we
R
use this
squared
more often.
calculates variance
This
in
is much accurate.
Well, you need both, right?
Yeah, but we only show this. We calculate this when we show this.
Yo,
We-
I
why would you
always use this for
This is more accurate.
I used to feel like
But if you don't have this, then this is meaningless. If you don't tell us what the relationship is, the variance is not important.
But the problem is that if you get a variance of 1 and you square it, it's still 1. So how do you know this?
Then that's great.
Yeah, but then, what do you mean by, if this is also 1, you square it, this is data.
Okay, hold on.
what?
Guys, where are you going? Get over here. Okay, in this case, approximate, then this case, r squared, this one, r squared is probably approximately 1. In this case, r squared is closer to 0. Because
But you square
It's
1.
not close to
So 1 squared is 1. So how do you prove this?
No, you're squaring all the
Same
data.
as
No,
this.
you're squaring.
no, I don't think you can just square the r value.
What?
I don't think that's
Math is a lie.
Yeah,
Are you
no.
sure?
If you put in the GDC, it doesn't like complete.
But then remember, you just
no,
square.
we did it. It's like it'll show you everything. R and R squared.
But I don't think you can just take square of
Yeah,
r.
sorry.
I think there's a different calculation. Although this says
That's
that
a
you
background
do.
information to write.
Let's a limitation. No, let's find that out. That doesn't work. Also, you're not. Oh, I see what you're saying. R squared is also going to give you 1. Yeah, I'm pretty sure there's a different calculation. I think I told those guys asked that question and I said yes, but I think that's wrong.
Ooh.
I'll find out.
Oh, what is
So variance. What does this really tell you? This means how
Close.
close is the data to the
Does you have to
trend line,
Remember?
right?
No.
How closely associated is the data to the trend line? See, because here, this is weird. This says
You
down
just
here,
have to
finding
square
r
it.
I
squared.
don't think. Like,
No, so r.
The chances of getting like
1 is
one
like.
is super hard.
Because I don't think this is gonna be 1.
See, this is weird. It just says squared.
Yeah, you just have to square it.
But if you no, that's not. Like,
I don't think this is gonna be 1.
Oh wait.
It's gonna be like somewhere.
Yeah,
Yeah.
of course. It's not going to be exactly 1. I feel like that's not correct.
Use
What?
usefulness of R
I
squared.
remember you just have to square it.
I'll find out. Anyway,
Oh, maybe I'm
Um,
stupid.
r squared is the square of the correlation coefficient. Yeah, no, it is right.
Yeah, you just have to
Is this
square
equation correct? Yeah, it is. Same equation. Okay, so we've covered the 3 things that we need to do for our analysis, people. Now, I want to finish with one last thing. Can you go? I want you to open. I want you to open in that zip file that I just sent you, William. What are you doing? In the zip file, can you open the zip file first? Unzip it. And I want you to open folder 9 and folder 10.
So
And
no, I'm so sure.
maybe one person open folder 9, one person open 10. Yes, open the examiner's marking scheme. Maybe someone else can open the other one.
This is the same as mine. What do you mean?
Okay, open 10 now. Go to the other one. Well, keep them open though.
I want to open it.
Mac user.
Okay.
Aren't you?
Now, compare. Can you put these side by side, sort of? Or just like so we can see both?
Do it. What?
Oh,
Yeah. So much
new-
so much work for a blackboard.
Oh, why is one PDF? Okay, can someone tell me, make this a bit smaller? What's the difference in the research question between these 2 IIs?
Research question? Where's the research? Oh, is there a relationship? This one.
Wait,
What?
where?
Country's human development index.
What? Where?
And citizen.
Top. This is the marked.
It's the
version.
exact same.
It's the exact same. Yes.
Bruh. Is there?
Okay.
Oh.
Look at the marks that they got though.
Plagiarism. This guy must have copied this one.
I do it.
No, there's no. It's not plagiarism. Let me explain to you where this came from. This is before when the IB brought the new science syllabus out in 2016. The II was a new thing, right? They had never done this like do your own experiment before. But they also a new thing was to allow data like secondary IIs for students to not have to do an experiment. Okay? So what they're doing, these are examples that the IB gave of what a data-based II could look like. They specifically gave two with the exact same research question, one that was obviously poorly done and one that was well done. Okay? Now, if you open the actual document itself, yes, I think, yeah, like that. Okay, and you compare 9 with that one has the notes, but if you just open that one. Okay, so 10. So 10 got the good mark or the bad mark?
Good mark. No, bad mark.
Bad mark. Okay, so if you just kind of scroll and then open 9 as well.
That's good.
Why is there 4 here?
Yeah, that's.
One has like examiners like comments on it. Okay, so just scroll past both of them and see like what kind of difference you can see.
His intro is long.
Mm-hmm.
Whose intro is longer?
9.
This guy's the guy who got good grade, right?
Yeah.
Mhm.
The
Good grade.
9.
The good boy.
Well, okay, so the key is to make a long intro. Understood.
They have almost the same data,
Wow.
but
I knew this will copy that one.
But this guy barely explained anything.
mm-hmm.
Whoa.
While you're doing, I want you guys to keep
There's
doing
no
that.
caption.
I have to find something.
Colon. Okay, and then average mean.
Continue.
This one is smaller. Oh, Mr. Osorio doesn't like small one.
Low.
Yo, this guy basically copy and paste.
I know, right?
Bro, if you want to copy, you gotta do it the other way. Wait, that's it?
Wait, what?
Right?
Wait, what?
Right?
That's all he has? Wait, no, he has
Oh,
more.
okay. Oh, page. Oh, wait. Yeah, but that's it. Page 3 of 3.
Oh,
Okay, this guy completely ignored the.
What's HDI again? Human Development Index.
you're juiced.
Is HDI actually Human Development Index?
Yeah.
Oh, just the length. Okay, so basically you have to write more.
Longer II equals
That's the
more.
that's the moral.
That's
the
the
morale?
conclusion.
Moral of the story.
So the other stuff in there as well, right? They give you like the examiner's notes, right? The other page that we had before. Not to mention more data. I mean, look at this.
This guy only mentioned like 5
5 dots.
comparing to I don't want to. How much is that?
Why does he have
Not
5
Scan
dots?
the camera.
Where do you get the
FBI
5
guy
dots?
is good.
It's a lot.
Those are his data points. He only has
Wait,
5 data
Can you
points.
go to the data table?
Oh.
So, no, this one. The guy with.
This guy doesn't even have data.
That's
Oh,
it.
The 5.
I was like, wait, what is that?
No, but how come he also have this?
Because he did a preliminary. He did like, so if you read initial exploration of the relationship, and then he found something like, and then he like expanded it.
Whoa,
Yeah.
so hard
So
work.
he found like further.
Yeah, so he did this first, and then he's like, okay, there is a relationship. Let me see if it's
Oh.
true if I add more data.
Also,
Whereas
these
this
are,
guy just stopped.
Yeah,
These
this,
are-
this guy's
I- I
BS.
yeah, and this
This
is
guy's lazy. He probably only have 1 day left.
3 of 3, so that's over. And then
7. Oh yeah, we just need
Yo,
to
I
write
saw
down.
this guy got 20.
Whoa.
I'm 21.
Whoa!
Whoa.
Even better.
Yeah, why are we looking at
The only difference is these ones aren't database, so these are
Oh,
actual
shit.
experimental ones.
And-
We should do experiments, I think.
So there's no point of looking at these.
Not for right now, but later
Not for right.
when you're planning your own retrain.
So are you saying that the most we can get is 19?
No,
Oh.
not at all.
So can we break the barrier?
That's right, break the barrier. Okay.
We have hope to break the barrier.
So the last thing I want to show you guys is I clicked on some of the links that are there that I provided, and sort of the data that you're looking for.
Yo,
For example, one of those links takes. Oh my gosh.
this guy even did like a map.
Dude, what is this guy? What's this man doing?
This guy did a map.
He's starting at EE. Did what?
Did a
Yeah.
map. And then he only got 19.
Good lord.
Why is this
Underrated.
Imagine we get 19 over this.
Yeah,
If I get 19, I'm satisfied.
What?
Like anything above 8.
Wait, what?
Anything above 8 is okay.
Oh no.
Everything above
Why?
10. Let's go.
Do we have to do the error bar?
Yeah.
The error bar?
No.
You can't do it.
How do you do error bars for
It's a
this?
data plot. So here's one example of the thing. So like this is the database of mortality. That means data of people dying
Wow,
due to various things. But it's pretty neat because you can choose any parameters you want. So here you can like
Whoa.
pick various diseases. So like pick something.
So we can start, we can brainstorm our
Yeah, exactly.
research.
Here, like, okay, circulatory things, right? You can do digestive. Okay, let's try something related to what we're doing. Digestive, you can do liver disease. Okay, I want to know number of deaths.
Gastric.
And then I can also choose a certain country. Let's pick
Costa Rica.
Costa Rica.
Canada.
And then this you can choose the years.
What?
If you don't choose anything, it chooses all of them. And I just press OK.
Okay.
And then I can go to graphs. Now, here's the thing. This is where you can't just use this graph.
What?
This is for taking data, because this is only one half of your data, right? I'm finding, this is just telling you the cancer,
Oh yeah, yeah. I need the other factor.
then you need another factor separately. What the hell?
Haha, scam. The WHO scam.
What did we pick? Costa Rica. Oh, I need all the years. Okay, let's pick a bunch of years here. Okay. And then table.
Boom.
Okay, here we go. So here, okay, so this one is not specific. This gave me all the countries, right? And gave me the years. This is how many people died from that thing that we chose, liver disease. And you can see there's obviously gaps. So this is where you get into like, oh, I really wanted to look at the incidence of liver cancer in Honduras
But
in
there's
2015. It doesn't exist.
Wait, why? Is it because
It's just not available. The data's not available.
Wait.
It might be available somewhere else, just not here.
Wow.
There's a different table so table B, I think, is just the country you chose. Here it is. There it is over the years. So this is a nicer thing. This is what you are looking for. This kind of stuff. Years, data, nicely side by side. What was table C? I don't know. Ah, number of deaths, both sexes. This might be world. Oh no, just Costa Rica. Yeah. It's just different ways of presenting the data based on what you chose, and then you can just adjust your parameters. So this is only one example of many websites where you can find. Here, WHO gives like lots of like charts like this, so you could use a chart and just like create your own data table based on the charts. Cancer today, this gives good visualization. So really, it's just a hunt for data. We can't set a due date until we know when school actually starts.
Oh yeah.
Wait, what?
Doesn't it start at the exact same time?
No.
I mean, I think it's still not 100%.
They said it has to be like after August.
I have a feeling that it's going to be
September.
later than we usually do.
Mid September. That's my guess.